Hello, welcome to ANS Solver. This is the seventh question of the paper. So as you can see, this is a parametric equation question. So we know these are the two equations which are given to me. Okay, at point P on the curve, the gradient is 2. Okay, so we need to show that the parameter P satisfies this equation. So for that, I need to know a very important thing. I need to know dy by dx can be written basically as dy by dt, correct, over dx by dt. Agreed? Because dt cancels, so I get dy by dx again. Agreed? So what I can do is I can calculate dy by dt first, because I have y in terms of t and x also in terms of t. So now the differentiation of dy by dt is basically phi t differentiation is 5. Okay, cos differentiation is minus sine 2t, but this will be multiplied by 2 because that's the differentiation of 2t, correct? Chain rule. So I get dy by dt as 5 minus 2 sine 2t. Now dx by dt. Okay, so dx by dt basically means the differentiation of this. So first I differentiate 2t, which is 2. Then I have the differentiation of sine, which is cos. So I get minus cos 2t, but again chain rule will apply and the differentiation of 2t will be multiplied, which is 2. Agreed? So now what I know is I know my dy by dx because I know the gradient is 2, correct? So I can equate 2 to 5 minus 2 sine 2t over 2 minus 2 cos 2t. Agreed? Because dy by dt over dx by dt. Okay? So now see, I need everything in terms of sine 2t and cos 2t. So what I basically need to do is I can write this as 2 into 2 minus 2 cos 2t is equal to 5 minus 2 sine 2t. So this can basically be written as, when I take 2 inside, I get 4 minus 4 cos 2t equals to 5 minus 2 sine 2t. Agreed? So now I need 2 sine 2t to be positive. So I can basically write this as 2 sine 2t minus 4 cos 2t equals to 5 minus 4. So I get 2 sine 2t minus 4 cos 2t equals to 1, which is basically the final answer and what I needed to prove. Okay? Now, so here, by first expressing 2 sine 2t minus 4 cos 2t in the terms of this, find the coordinates of P. Give each coordinate to 3 significant figures. So now, I have 2 sine 2t here minus 4 cos 2t, and I need to write this in the form of r sine 2t minus alpha. So now if you see, this is the sine compound angle formula, which can be written as r into sine 2t cos alpha minus cos 2t sine alpha. Agreed? The sine a minus b formula. So now I can take r inside the bracket to get r sine 2t cos alpha minus r cos 2t sine alpha. Agreed? So now I have sine 2t here, sine 2t here. Correct? I need to basically compare both of these equations because I know both of them are equal. So the coefficient of sine 2t here is r cos alpha, which is now equal to the coefficient of sine 2t here, which is 2. In the same way, I have cos 2t here, I have cos 2t here. The coefficient of cos 2t is r sine alpha, which is now equal to 4, because that's basically the coefficient of cos 2t here. So now I can write this as cos alpha equals to 2 over r and sine alpha equals to 4 over r. Now how do I calculate this? I always recommend you to make a triangle. Okay, make a right angle triangle. I know this is 90 here. Okay, and I know this angle here is alpha. Now I know cos is basically the adjacent over the hypotenuse. So the adjacent is 2, the hypotenuse is r. The same way I know sine is the opposite over the hypotenuse. So my opposite is 4 and my hypotenuse is r as it is. So what I basically need to do is, I know r will be equal to the square root of 4 square plus 2 square using simple Pythagoras. So I'll get the square root of 16 plus 4, which is basically r is equal to the root of 20. Okay, so now what I can simply do is, I know sine alpha is equal to 4 by r. So I can write this as sine alpha equals to 4 by root 20. Correct? So I can write this as alpha. Make sure they have asked you to maintain the radian mode. So make sure on the calc you are on the radian mode. Okay. So now you can simply do sine inverse of 4 by root 20. So when you do this, you get your answer basically as 1.107. Okay. So the form I get, I can write this as root 20. Okay. Sine 2t minus alpha, which is 1.107. Okay, so now I know I need now to find the coordinates of P. For that, I need the value of t first, because I can simply just substitute t here and get my value. Now, I know here this is equal to 1. So I can simply say that the root of 20 sine 2t minus 1.107 is equal to 1. So I can write this as sine 2t minus 1.107 is equal to 1 over root 20. I need to make sure I'm on the radian mode, and I can do the sine inverse of 1 over root 20. So when I do that, the value I get is simply 2t minus 1.107, which is equal to 0.22551. So now I can say 2t is basically equal to 0.2551 plus 1.107 plus, okay, not minus, because it comes to the other side. Okay, when I do that, the value I get is 1.3325. So I can write t is equal to 1.3325 over 2. So I can say t is now equal to, when I solve this on the calc, the value I get is 0.666. Okay, so now we need to find the x coordinate, or the coordinates of P. I know x is basically 2t minus sine 2t. So x is equal to 2t minus sine 2t. So now I can basically write this as x equals to 2 into 0.666 minus sine 2 into 0.666. So now my x will basically be equal to 2 into, so I can just solve this on the calc. Make sure you are on the radian mode. Okay, I'm repeating myself because many students do commit this mistake. So now when I solve this on the calc, I get my answer as 0.361. Okay, to 3 significant figures. Now I know y is equal to phi t plus cos 2t. So I can simply write this as phi t plus cos 2t. So now in the same way, I can substitute the value of t, which is 0.666, plus cos 2 into 0.666. So now I can write this as y equals to 5 into 0.666 plus cos into 2 into 0.666. So when I solve this, the answer I get is simply 3.57. So these are basically my coordinates of P. Okay? Yeah.